Good morning, dear students, and welcome back to our online class. I hope you have enjoyed your short vacation and you are now again filled with more energy, new energy to learn new things through our online classes. Now, before we went for our vacation or short vacation, third card test break, we were studying about the study of first element, hydrogen. And we have already learned about the properties of hydrogen, how hydrogen can be prepared by the action of water, by the action of metals on acids and alkalis. Now, in our today's class, we are going to learn the laboratory preparation of hydrogen and its collection and some precautions which we need to take and the removal of impurities from the hydrogen prepared. So let us start our today's class. Laboratory preparation of hydrogen. Now, to prepare hydrogen in the lab or laboratory, we need certain reactants, and the reactants are granulated zinc. Granulated zinc means zinc which are not powder. They are grain like zinc, little bigger in size, flat in surface area. They have larger surface area. Okay. Now, granulated zinc dilute hydrochloric acid or dilute sulfuric acid. So we need two reactants. And what are those two reactants? One is zinc. What type of zinc? Granulated zinc. What is the symbol of zinc? Zn. And either dilute hydrochloric acid, this is HCl, or either dilute sulfuric acid, H2SO4. We can use any of the two acids, but we do not use nitric acid. And why we don't use nitric acid, we have already discussed in our previous class, because nitric acid is a strong oxidizing agent. Therefore, the hydrogen produced will be converted or oxidized to water. Now, these are the reactants. Now, how to carry this reaction in the lab? Now, in order to carry this reaction of granulated zinc and dilute hydrochloric acid or sulfuric acid, we need our apparatus, things to carry out the reaction, and they are a round bottom flask, a thistle funnel, delivery tube, trough, and one gas jar. Okay. Now, let us see how to carry this reaction. Now, first we have to put our zinc granules or granulated zinc in the round bottom flask over here. Now, this round bottom flask need to be covered by a cork, airtight cork, which must have two holes. Through one hole, a thistle funnel is inserted, dip in the round bottom flask just above granulated zinc, and through another hole a delivery tube is fitted in this way. Okay, and this delivery tube enters the gas cylinder or the collecting vessel, okay, in the trough. Now, through the thistle funnel, we need to pour either dilute sulfuric acid or dilute hydrochloric acid drop by drop, okay, by controlling with this knob. Okay. Now, once or knob, or we also call this a stopper. Now, when we add acid into this granulated zinc, now a chemical reaction takes place. Now, what is that chemical reaction? Zinc reacts with, if we are taking hydrochloric acid, reacts with hydrochloric acid to give zinc chloride. This is a salt produced. Okay, zinc chloride plus hydrogen gas. Always remember, we represent gas by writing arrow pointing upward. This represents the product is gas. Now if we use sulfuric acid instead of hydrochloric acid, the product form will be, instead of chloride we will get sulfate. So this will be zinc sulfate. Again, this is also salt plus hydrogen gas. So in both the cases we get metal salt. What is the metal? Zinc. Metal salt and hydrogen gas. Okay boys, so now why zinc granules are preferred instead of zinc dust or powder? The reason behind using zinc granules is zinc granule contains some impurities over there, impurities such as copper, and this copper acts as a catalyst. And what does a catalyst do? Catalyst increases the speed of the reaction. So zinc granules contains impurity such as copper, which increases the speed of the reaction or the rate of production of hydrogen gas. Therefore, zinc granules are more preferred over zinc powder or zinc dust. Now what we will observe when we carry this reaction, as soon as we add acid to this zinc granules, hydrogen gas, zinc salt produced will remain in the round bottom flask only, but the hydrogen gas being lighter, they will rise up, they will enter this delivery tube, and through the delivery tube they will now enter the trough containing water, and we will observe some bubbles of gas being produced, and this production of bubbles in water is called effervescence. The production of bubbles in water or liquid medium is known as effervescence, and this proves that some gas is being produced or some gas is coming. So this effervescence proves that a gas is being produced, and we all know by the chemical reaction the gas produced is hydrogen gas. Now we need to collect this gas. So how do we collect this gas? Now this hydrogen gas produced is collected by the downward displacement of water. Downward displacement of water means the cylinder is kept upside down, okay, bottom point at the top and the open end at the bottom. So, and over here in the trough we have water. So the water will be inside the jar first. Now when gas starts coming over here, this gas being lighter than water, it will rise up, and when gas rises up, this gas exerts pressure. Where does that gas exert pressure? Downward. So this gas exerts pressure downward on water, okay, and slowly as more and more gas starts coming over here, there will be more pressure exerted on the water, so water moves downward, and larger the quantity of gas, more down the water will be displaced. That's why this process is called downward displacement of water. So what you have to remember, the hydrogen gas produced is collected by the downward displacement of water. Okay boys, now why we collect hydrogen gas by downward displacement of water? Why can't we collect gas directly in a dry vessel instead of using water? Why can't we do that? We can collect hydrogen gas without using water, but why do we prefer downward displacement of water technique? There is a reason behind that, and the reason behind that is hydrogen gas is insoluble in water. Virtually insoluble means it is very, very stable. It does not mix with water. Okay, that is the first reason. Second reason is this hydrogen gas is explosive when it comes or mixes with air. So if hydrogen gas is collected in a dry container, so inside the dry container there will be air. So when we collect hydrogen in dry container, due to presence of air in that dry container, now hydrogen reacts with some of the gases present in that air, and which might be an explosive mixture. Okay boys, so therefore in order to avoid these two difficulties, we prefer collecting hydrogen gas by the downward displacement of water. Now the hydrogen gas prepared also contains some impurities. In fact, we can see over here there are 7 impurities. What are those impurities present? They can be hydrogen sulfide, sulfur dioxide, oxides of nitrogen, phosphine, pH3, arsine, carbon dioxide, and water vapor. So the hydrogen gas which is collected over here in the gas jar, it might contain these impurities as well. So in order to get pure hydrogen, now it becomes very important to remove all the impurities from hydrogen passing through this delivery tube. Now once the gas is collected, now we move on to another stage, that is purification of hydrogen gas produced. Now the impurities which can be there in hydrogen gas, they can be removed by using some purifying agents. They are, number 1, silver nitrate solution. Now this silver nitrate solution, through the silver nitrate solution we can pass the collected gas, okay, and this silver nitrate solution will remove arsine and phosphine. Okay boys, so to remove arsine and phosphine, what do we have to do? We have to pass the collected gas through silver nitrate solution. Now there are still some more impurities left. So for example, hydrogen sulfide. So to remove hydrogen sulfide, what do we do? The gas which is passed through silver nitrate, it is again passed through lead nitrate solution, and this lead nitrate solution removes hydrogen sulfide, and the reaction given is this one. It follows this reaction. Lead nitrate combines with hydrogen sulfide to produce lead sulfide and nitric acid, and both this will be solid and this will be liquid, and we are interested in gas. Now again there are some impurities left, such as sulfur dioxide, carbon dioxide, and oxides of nitrogen, and all these impurities can be removed by passing the remaining gas through caustic potash solution. Okay, through caustic potash solution, in this solution the sulfur dioxide will react with potassium. Caustic means potassium hydroxide. Caustic potash means potassium hydroxide. So potassium hydroxide will react with sulfur dioxide to produce potassium sulfite, water. This is solid and this is liquid. Carbon dioxide reacts with potassium oxide to produce potassium carbonate and water. This is solid, this is liquid. Oxide of nitrogen reacts with potassium hydroxide to produce potassium nitrate, potassium nitrite, and water. These two are solid and this is liquid. So now all the impurities are being removed either in the form of liquid or in solid, and finally we are left with gas. Again, in the final stage there might be some water, and this water can be in gaseous form like water vapor. So we are finally left with water vapor and hydrogen gas. Now to remove water vapor, if we remove water vapor, then we will get pure hydrogen gas. Now how can we remove water vapor? By using some drying agents. Now drying agents, they absorb the moisture from the gas, leaving gas as pure gas, and we can use either anhydrous calcium chloride, or fused calcium chloride, caustic potash, phosphorus pentoxide, any one of them. You can use any drying agent to remove water vapor from the hydrogen gas. And finally, what we get? Pure hydrogen gas. The whole process can be carried out by making arrangement like this. In the first bottle flask, we have silver nitrate, which removes arsine and phosphine. In the second flask, we can use lead nitrate solution, which removes hydrogen sulfide gas. In the third flask, we can use caustic potash solution, which removes impurities such as sulfur dioxide, carbon dioxide, and oxides of nitrogen. And finally, we get gas mixture of water and hydrogen. Now this mixture of gas is passed through anhydrous or fused calcium chloride, a drying agent, and this drying agent will absorb water, and the gas which comes out from here will be now pure dry hydrogen gas, and it is now again collected in a separate jar. So this is how we produce hydrogen gas in the laboratory. Okay, and we all know the most preferred metal to produce hydrogen gas is zinc. Okay, so these two reactions you have to learn. You have to remember the diagram, you have to remember the method of collection of hydrogen gas, and the impurities, removal of impurities of hydrogen gas passing through the different funnels. Is that clear? This much for today, boys. I hope I have made you understood or understand the laboratory preparation of hydrogen and some precautions that we need to take. We'll meet in another class. Till then, stay safe and do all things well.